Section 338.12b of the National Electrical Code, or NEC, addresses the allowable uses of service entrance cable, and more specifically, the requirements for the neutral conductor size in certain service applications. Focusing on pipe services, understanding the implications of this section is crucial for ensuring code compliance and safe electrical installations. The NEC outlines specific guidelines for the sizing of the neutral conductor in relation to the phase conductors. These guidelines ensure that the neutral conductor is adequately sized to carry the anticipated neutral current, which is especially important in systems with nonlinear loads that can generate significant harmonic currents. For pipe services, the NEC mandates that the neutral conductor must not be smaller than the size of the largest branch circuit conductor. This requirement is put in place to handle the potential for unbalanced loads and harmonic currents that can flow in the neutral conductor. If the largest branch circuit conductor is rated for 200 amps, then the neutral conductor serving the pipe service must also be rated for at least 200 amps. Understanding what constitutes a pipe service is essential. A pipe service generally refers to an electrical service where the conductors are run through a conduit or other form of protective raceway. This is in contrast to service entrance cable, such as SEU or SER cable, which may have different neutral sizing requirements under certain conditions. The NEC provides specific tables such as those found in Article 310.16 and associated tables to determine the ampacity of conductors based on their size, insulation type, and operating temperature. Selecting the appropriate conductor size for both the phase conductors and the neutral conductor requires careful consideration of these ampacity tables and any applicable dating factors for ambient temperature of multiple conductors in a raceway. The phrase largest branch circuit conductor refers to the conductor with the highest ampacity that supplies a specific load or a group of loads. This is not necessarily the same as the service entrance conductors themselves, but it is the largest conductor used in any of the branch circuits originating from the service panel. For example, if a residence has a 200 amp service but the largest branch circuit is a 60 amp circuit for an electric range, the requirement in 338.12b does not apply to the entire service entrance. It applies to the sizing of the neutral for the specific branch circuit if it were run in conduit separately from the service entrance. When dealing with service entrance cable like SEU, specific rules apply regarding the reduction of the neutral conductor size. These rules are typically found in NEC section 310.15b7 for dwelling services. It allows the neutral conductor to be smaller than the ungrounded conductors under certain conditions, primarily based on the anticipated load and the characteristics of the service. However, this reduction is not universally applicable and is subject to limitations based on the calculated neutral load. The requirements for service entrance cable differ from those for pipe services. Understanding these differences is critical for code-compliant installations. It is important to always refer to the latest edition of the NEC and consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. This is crucial for the safe and reliable operation of electrical systems. When using SEU cable for a service, the NEC permits a reduced neutral size based on a calculated neutral load. This calculation takes into account the unbalanced load and the nonlinear loads that contribute to harmonic currents. However, this reduction is not allowed for pipe services, which require the neutral to be at least the same size as the largest branch circuit conductor. Understanding the specific requirements for different types of services is essential for proper installation. It's also vital to remember that local amendments to the NEC may exist, and these amendments can further modify the requirements for neutral conductor sizing or other aspects of electrical installations. Always check with the local authority having jurisdiction, or OJ, to ensure compliance with all applicable local codes. The NEC provides tables and examples to aid in calculating the neutral load and determining the appropriate neutral conductor size. These resources are invaluable for ensuring that the neutral conductor is adequately sized to handle the anticipated current. When installing a 200 amp service, the choice between using a SEU cable or a pipe service will impact the neutral sizing requirements. If SEU cable is used, a reduced neutral may be permitted based on the calculated neutral load. However, if a pipe service is used, the neutral must be at least the same size as the largest branch circuit conductor. It is important to understand the implications of each choice. Proper grounding and bonding are also critical aspects of electrical installations. The grounding system provides a low impedance path for fault current, which helps to protect against electrical shock hazards. The bonding system ensures that all metal parts of the electrical system are electrically connected, which also helps to minimize the risk of electrical shock. The NEC contains specific requirements for grounding and bonding, and these requirements must be followed to ensure a safe and reliable electrical system. In addition to the neutral conductor size and requirements, other factors must be considered when installing an electrical service. These factors include the overcurrent protection, the service disconnect, and the grounding and bonding system. All of these components must be properly sized and installed to ensure the safe and reliable operation of the electrical system. The selection of conductors for an electrical service should also take into account the ambient temperature and the presence of other conductors in the same raceway. The NEC provides directing factors that must be applied to the conductor ampacity when these conditions exist. Failing to apply these directing factors can result in overheating of the conductors and a potential fire hazard. When working with electrical systems, it is always important to prioritize safety. Always to energize the circuit before working on it and use appropriate personal protective equipment, or PPE, such as gloves and eye protection. If you are not qualified to work on electrical systems, hire a licensed electrician to do the work. The NEC is a complex document, and it can be difficult to understand all of the requirements. If you have any questions about the NEC, consult with a qualified electrical inspector or engineer. They can provide guidance and ensure that your electrical installation is compliant with all applicable codes and regulations. Furthermore, ongoing education and training are essential for staying up to date with the latest changes to the NEC and best practices for electrical installations. The electrical industry is constantly evolving, and it is important to stay informed to ensure that you are providing safe and reliable electrical services. In summary, when dealing with a 200 amp service, the choice between SEU cable and a pipe service dictates the neutral sizing. SEU allows for a potentially reduced neutral based on load calculations, while a pipe service necessitates a neutral at least as large as the largest branch circuit. Always consult the NEC local codes and qualified professionals for compliant and safe installations.